Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Muslihuddin bin Muhammad Yassin. Today, I would like to present my final year project titled Human Detection with Different Speed Using LTE Frequency and Passive Forward Scattering Radar System. First of all, for introduction, the radar consists of two types, with each monostatic and bistatic. For the monostatic radar, the transmitter and receiver is located at the same place. While for the bistatic radar, the transmitter and the receiver is located at the different place. In bistatic radar, there are an application named forward scatter radar. It also uses the bistatic, which the transmitter and receiver at different place, but it is include bistatic angle, which is around 180 degree. For more information, I will explain in my case study, which is passive forward scattering radar. For passive forward scatter radar, I use passive signal, which is LTE signal as transmitter and passive radar as receiver. When target cross the baseline, 180 degree of bistatic angle. Next, Nemo Handy has been used during the experiment. Nemo Handy is used to detect the LTE signal strength, record a value of RSRP and RSRQ for the classification of LTE signal strength. Okay. Next, for the problem statement and objective. The first problem statement is human trafficking, and then the second is illegal entry of person into country, and then the third is border protection is not secure. As you all know, there are a lot of incidents involving human trafficking and intruders crossing Malaysia border. For example, incident at Malaysia-Indonesia border and incident in Lahad Datu. Next, for the objectives. The first one is to understand the process of passive forward scattering radar for human detection. Then the second is to detect the Doppler signature of human with the different speed based on passive forward scattering radar system with using LTE frequency. And then the third is to classify the Doppler signature of human with different speed. Okay, next for a methodology. The first one is experimental site. And the first location is at Kampung Bangkun. Kampung Bangkun is located at Sungai Pelet, Selangor, which was a rural area. This area does not have a particular high concentration of LTE commercial tower, and the distance between the LTE transmitter and the passive radar receiver is 128.33 meters. Okay, next for second location is at Batu Laut, which is located at Tanjung Sepak, Selangor. Okay. The distance between the transmitter and the radar receiver is 157.57 meters. Okay, next location is at Maiz, and the distance between the transmitter and the radar receiver is 146.60 meters. For my second methodology, is the human detection for different speed. There are a transmitter and a passive radar receiver. The target is a human will crossing the baseline. After cross the baseline, there is a Doppler signature as shown in slide. When the transmitter and the receiver facing each other, we will get a bistatic angle, which is 180 degree. This we call passive forward scattering radar. Okay, next I will explain about my activity for detect human with different speed. The first one is casual walking. Target will crossing the baseline with speed of 3 km per hour. And next for jogging with 7 km per hour. And then the last is run with 13 km per hour. All these activities imitate the illegal entry of invaders. Okay, next methodology is data processing. The first process is data collection. The data will collect for 20 seconds in time domain. Okay, and then the second is data selection. The data will be selected into a 2-second time domain consists of Doppler signature of activities. And next is data denoise. The data denoise will reduce the unwanted signal. And next, we proceed to the power spectral density, which is PSD. The PSD is the inversely the time domain result into a frequency domain. Next is principal component analysis, PCA. The behavior of human moving targets are characterized by their spectral characteristics using principal component analysis, PCA. And the lastly is classification. For data classification, it will give the percentage. Okay, next, we move to data processing for the Nemo Handy. The first one is Nemo Handy is used to detect the LTE signal strength. And then we proceed to data recording, and then data selection to plot the graph, and the lastly is we do a classification for LTE signal strength. Let's continue with result at Kampong Bangkok. All these figures shows the time domain for frequency 1.8, 2.1 and 2.6 at different activity. As you can see, CW, which is a blue line, has the longest time taken because the person just walked casually with speed of 3 km per hour. For this frequency, the highest signal level is run, which is a black line, which is due to the Doppler signal from human highest speed. As the figure shows, the amplitude of the Doppler for frequency 1.8 GHz is the highest between the frequency 2.1 GHz and 2.6 GHz. This is because there are many providers for the frequency 1.8 GHz at Kampong Bangkok, which is also proved by the Nemo Handy. Next, we move to power spectral density. As we can see, for all frequency, run has the highest value for the Doppler frequency, and the CW, which is a blue line, has the lowest value for Doppler frequency. This was proved by the theory of Doppler frequency, which is frequency Doppler equal to 2V over lambda. Next, we move to principal component analysis. As we can see, all the clusters do not overlap with each other. For information, the blue cluster for CW, red for jot, and black cluster for run. Due to the non-overlapping, for all frequency, the total classification percentage we got at Kampong Bangkok are 100%. Continue with result at Batu Laut. For time domain, same with Kampong Bangkok, run, which is a black line, has the lowest time taken compared to jog and CW. Okay, next for power spectral density, as we can see, the highest Doppler frequency is run, which is a black line, and the lowest is CW, which is a blue line. This result show for all the value of Doppler frequency, 1.8 GHz have the highest value due to the transmitter frequency, which proven in equation FD equal to 2V over lambda. Okay, next for principal component analysis, for 1.8 GHz, each cluster situated away from each other. For 2.1 GHz and 2.6, each cluster is overlapped with each other. At Batu Laut, the frequency of 2.6 GHz is the worst that can be seen in the PCA graph at Batu Laut, distributed in comparison with Kampong Bangkok because of the LTE signal strength. Okay, for the percentage, for 1.8 GHz, they are 100%, and for 2.1 GHz, they are 96.86%, and for 2.6 is 94.45%. Okay, next we go to result at MAPS. For the time domain, run has the lowest time taken between the CW and the jog because the speed for the run is 13 km per hour. Okay, next for the power spectral density, for MAP show that run activity has the greatest value of Doppler frequency compared to CW and the jog. For the observation, the value of the Doppler frequency for run has the highest value compared to CW and the jog due to the higher speed of activity. Okay, next we proceed to the PCA. As you can see, only frequency 2.1 GHz, the cluster overlap with each other, while the other frequency, they are not overlap. From all the result, after PCA, the cluster of classification at Batu Laut is the worst, scattered in the comparison with Kampung Bangkon and the MAEPs, due to the lowest EC power from the LTE tower base station. For the percentage for at the MAEPs, 1.8 is 100%, and then 2.1 is 97.23%, and then for 2.C is 100%. Next, we proceed to the result for the classification for Nemo Handy. Based on the figure, all these LTE frequency are in excellent condition at Kampung Bangkon, which the strongest LTE signal strength is 1.8 GHz. This is because the wavelength for 1.8 GHz is greater than 2.1 GHz, and it is proved by the formula lambda equal to C over F. At MAEP, the stronger LTE signal strength is 1.8 GHz, followed by 2.6, and the last is 2.1 GHz. The comparison LTE signal at Kampung Bangkon is the strongest than the MAEP because the population MAEP is more than Kampung Bangkon. At the Batu Laut, the stronger LTE strength is 1.8 GHz. This is shown in PCA at Batu Laut, which is the data do not overlap with each other compared to the frequency 2.1 and 2.6 GHz. As the conclusion, passive forward scatter radar (PFSR) system able to detect the human activities at a different speed. And then for the next, each activities have unique Doppler signature based on their speeds. The last one is the human activities with different speed by using LTE can be classified successfully into their own cluster by using principal component analysis (PCA). That's all from me. Thank you.